Very good morning to one and all present here. On behalf of Vidyavardhaka College of Engineering, I, Vidyashri KP, Assistant Professor, Department of Information Science and Engineering, would like to welcome you all for the Faculty Development Program on Artificial Intelligence and Natural Language Processing, organized by Department of ISC. It's my pleasure to give you the overview of the FDP conducted this week. So today for the first day of the FDP, we have Dr. Devraj Verma, Jain University, Bengaluru, speaking on the introduction to AI and NLP. Day 2, we have with us Dr. Pratibha RJ, JSS Science and Technology University, Mysuru, who will be delivering session on NLP and its challenges for AI. Day 3, Dr. Mahananda BS from JSS TU, who will be giving us insights on applications of AI. Day 4, Dr. Vinuta DC, Vidyavardhaka College of Engineering, Mysuru, speaking on machine learning algorithms. Day 5, we have with us Dr. Anand Kumar, NITK Surathkal, Mangaluru, will be delivering talk on application of NLP. Now I request our beloved HOD, Dr. A.B. Rajendra, to address the gathering.
Thank you, Vidyashri Madam. Good morning, everyone. I am happy to welcome you all for the 5-day FDP. As we all know that machine learning and artificial intelligence has taken a center stage today in various applications of technology. As researchers and students of technology, we should know that artificial intelligence has acted as the main driver of emerging technologies like big data, robotics, and IoT. And it will continue to act as a technological innovator for the future. With this, I wish all of you great learning sessions ahead during the week. I welcome all of you, and I thank the organizers for giving opportunity to speak a few words. Thank you.
Thank you, sir. We welcome you also for the session. Now I request Professor Naveen Kumar to introduce the speaker for today's session.
Thank you, Vidyashri ma'am. It's my pleasure to introduce our today's resource person, Dr. Devraj Verma C, Associate Professor, Department of Computer Science and Engineering, Jain University, Bengaluru. So he has over 15 years of experience and served in various institutions like Dayanand Sagar College of Engineering, PS Institute of Technology, and then Krishna Institute of Technology. So he has published over more than 25 papers in reputed journals and conferences. He is currently guiding around 8 research scholars under him. His areas of interest are natural language processing, artificial intelligence, and machine learning. So it's our pleasure to have you as our resource person for today's, sir. Thank you. Over to you, sir. Devraj Verma, sir.
Thank you, sir. Thank you for introducing me. I would like to thank for the management of the College of Engineering, the department, and all the organizers providing me an opportunity to present the knowledge on AI and NLP in today's discussion. Okay, I'm audible, right? Hello.
Sir, you are audible, sir.
Hello.
Sir, you are audible.
Yeah, I'm audible, right, sir?
Yes, sir.
Yes. Okay. Okay. Today's session is on introduction to AI and NLP. What is the agenda and objectives of today's session? First is we'll have an introduction to the artificial intelligence. What is an AI? How the machines think like humanly and acting rationally. Then intelligent agents. We'll have an introduction to the intelligent agents, structure, performance, types of an AI artificial agents, environments, and the type and its types. where the agents can be deployed, as plus we see how to improve the performance of the agent using different strategies. We can be informed and uninformed strategies of it. Then we learn certain problems in NLP and what are the approaches, how we can resolve problems that occurs in NLP, natural language processing, and we'll have a thorough understanding of the process of NLP. These things will be covered in today's session. Therefore, we know what is an AI. AI is nothing but it is a branch of computer science where the human capabilities, whatever the normal human beings are going to perform the task, those tasks need to be done by the machines. Therefore, in earlier days, it is also seen that the brain, the philosophical or psychological concepts, if we compare how the normal human brain is going to function. It is a collection of neurons where each neuron will connect with each other, and the neurons cells are going to ignite with some task or an activity, then only they get an active in a human brain cell. Therefore, how these normal biological neurons are going to act in the normal human brain. In a similar way, the intelligence behavior can be exhibited by the machines, where each task will relate to the functionality of the neuron cell or a human brain. This is a first term. AI was the first term which has been coined by the John McCarthy at a Dartmouth conference in 1956. There was a one famous conference which was held in the Dartmouth by various American scientists as well as academics, industries. So many people were participated in that conference, and John McCarthy was the first person who has introduced this particular term called as artificial intelligence, and he defined that artificial intelligence is nothing but a simulation of the intelligent processes by the machines. The similar way how the brain is going to function in order to exhibit the natural and human intelligence, the same capabilities can be expressed by other machines, where the large amounts of data with a fast and iterative processing, as well as more powerful algorithms for AI to become a powerful. It mainly depends upon algorithms which are very powerful. Speaking to about what we call as search techniques, the search techniques in AI, the search algorithms makes this AI as one of the most powerful in the world, where it can automatically recognize many of the things in the environment and process the data as per to the requirements, and we can see analysis on data. Therefore, this AI process or human intelligence process, which normally occurs in the human brain, but also we can simulate certain other tasks. I can say where intelligently we can solve the problem. Intelligently, the problem can be solved. Therefore, what could be a variety of activities that are required in order to do this intelligent behavior? What type of data and what are the processes that are involved in order to make a machine as an intelligent and which can exhibit the intelligent behavior as the normal human beings are going to exhibit. Therefore, first thing is we can put in an application called as a speech recognition. Therefore, normally when any person, for example, calls over a telephonic conversation, immediately either a name is saved or not. If we are familiar with that particular person, and in the earlier days or in the past, if we have been met that person, in some part of the human memory or a brain, that person's voice has been stored, as well as recognition details will be stored normally in the human brain or neuron cells here. Therefore, as soon as any person calls over a telephone, even he calls after 6 months or a year also, but if we have met the particular person, immediately our neuron cells will activate those particular task I can say, which already has been stored with that person, where a year back you have been heard the voice, immediately you will get recognized that particular person's voice, and you'll start having the conversation with that person. This is how the speech means. Already the pattern of that particular speech of that person has been stored in your human brain, and even after a year, if you meet that particular person, you recognize how this is possible, because the patterns you have been stored in your brain. There's so many patterns of voices of millions of people you have been stored. But if he is a person who is very familiar to you, that will matches with the earlier signals which are stored in a neuron cells. Then when the two signals are going to coincide or match with each other, then it means that it has been recognized that particular voice of that person here. This is how the speech recognition, where the one part where the AI can be applied like that, you can see. Then learning, in order to recognize or do any task, learning is of course a very important criteria which is required by the humans, because without that thing can happen here. Even if we take an example on baby also, he doesn't know anything about the real facts in the environment. As it ages, as the days passes day by day, it start learning the new things, and those things will be whatever the things it sees in the surrounding environment, all those things will be stored in the small baby, or even a small baby, or a 3 months baby may be there, 6 months. See, over a period of time, the learning increases, the learning capabilities of that baby also increases, and all things what it sees around the environment will be stored in the brain, and the neuron cells will actually stores that information, and whenever it is required, the information will enables the baby to do the certain task in the environment. For example, let us take when the baby is going, 6 months baby is going near to the fire. Once first time it doesn't know that the fire is going to harm it. Then once it knows that the fire is going to harm it for the first time, the next time it comes to know that it should not go there, because the fire is going to harm the hand of that baby if it moves towards the fire. Therefore, that information has been, this is a learned, because over a period of time, from month to 2 months, 3 months, 6 months, over as the time is going to pass from year on year or a month on month, it is learning the new things, and all the new things will be stored in the neuron cells of the human brain. Therefore, accordingly, the planning, certain things are also needed, because any task need to be done. If the information is there, yes, every information has been stored into a brain's neuron cells. Then the next time when the baby is 1 year old, automatically it knows that in a house, that environment, where is a kitchen, where is my father, where is a dining table, where is a bathroom, where is a toilet, everything it knows, because after an year it knows everything about the surrounding environment, and something it has to do some task in that particular environment. If we say that, okay, go and get the pen from a okay, go and get the pen or a book from cupboard, like that, if you say, it immediately goes there, because it knows that it won't go and search in a kitchen, or I can say hall or some other room like that. Directly, because it knows the information is known to that one-year-old baby, that where is the cupboard in the home, because throughout the 1 year it has been learned that environment, where are the things in the home. Therefore, accordingly, when we say that go and get a pen or a book, immediately it goes to the cupboard where the pen or a book is there, and it gets it. And if we tell that go and get a half liter of a milk from a shop, yes, immediately it knows that where the mummy is going to get a milk every day in the morning, 8 o'clock. It knows what the mummy has did. She went to some other alternative shop and got it. Similarly, planning can also be done in that 1 or 1.5 year baby also. When we say that go and get some item from a particular store, if that item is not there in that store, it will not come back without that item. It will plan. So, okay, in the past history, it recognizes that, okay, when there was no particular milk in that store. My mummy went to some other store and got the milk. In the same similar fashion, it plans accordingly. See, the planning starts here. It plans, okay, this is not, if this in this shop, it is the item is not there. Oh, can I get the item, same item? Yes, of course, we can hiring a shop like that. Yes, then it goes there and it goes there like this. It tries to plan accordingly in order to meet the task environment, in order to reach the goal. Okay, fine. This is about the problem and planning, and finally the problem whatever has been given to that baby in order to get an item. Definitely sure it is going to get an item within a stipulated period of time. Okay. This is how what is an AI, how to define an AI, the goals and what are the tasks and task environments. Everything should be fit into that particular environment, and accordingly the machines should do the task for us. Now replace the baby in terms of some robotic agent or an agent which does your daily household activities. I can say, okay, going and getting the milk, maybe there, or going and getting the bananas or flowers, etc. Suppose if you have been deployed an artificial intelligent agent at your home in order to do your daily task, yes, of course, it has to respond to the task which are being given to it, right? Therefore, all these activities or tasks that can be performed by that particular what you call as a particular agent which has been deployed for performing the day-to-day activities for you at the house.
Excuse me,
So
sir.
AI can
Excuse me, Davis.
yeah.
Sir, your voice is
Hello.
not audible properly. So can you remove the earphone or can you place the proper? Sir, your
Yes,
voice
yes, yes,
is
yes.
not audible properly. So can you remove the earphone or can you place the proper?
Now, sir. Yeah, I think now it's audible. I just unplugged and once again I plugged in. AI is a broad field. I can say it includes the various reasoning, knowledge, planning, NLP, as well as all these capabilities were integrated into that artificial intelligence machine in order to perform tasks for humans efficiently. Therefore, the main goal of the artificial intelligence is to build such machines that makes intelligent decisions based on the past experiences. What I told as past experiences, that can learn and their learning capabilities. We can say that it can perform the tasks which are similar to the human task, I can say. Therefore, what is this A and approaches? What are the different approaches? How to define an AI here? Human capabilities and rationality, as well as thinking and acting phenomena. How they whether they are going to think like an humans, we can say that if they are thinking like an humans, we also say that it is an AI machine, because we can build a machine which can think like a humans, or we can think rationally. What is the difference between thinking like humans and thinking rationality? In the sense is doing the right thing here. Whatever the machine does, it does the right thing because it has been trained in such a way that it performs all the tasks which are similar to the I think power has which are similar to the human like tasks here. Acting that is systems that act like a humans here, not only thinking like a humans, because as far the what you call as a psychological perspective is concerned, or thinking, that is, we are building the machines which are thinking like a humans and doing the things rationally like a humans only, right thing like a humans only. When you think and do the certain tasks, they are right tasks normally called. Then another is acting like a humans here, that is systems that act like a humans and act rationally like a human beings here. There is acting like a human means exact behavior like a human beings only. How the person is going to behave, this particular machine also behaves like a person only, like the particular person. For example, a tutor, I can say, for example, we can have a machine which gives the explanation or like a teacher only. Therefore, it is acting like that particular teacher. That is nothing but acting, and what does it performs those actions? All the actions are really like humans only, and they are doing the right actions, I can say. Therefore, we have these perspectives, that is the four approaches that have been defined: acting humanly, that is thinking humanly, and act rationally, think rationally. We'll have detailed about this. Alan Turing, he has been performed one test called as a Turing test in order to prove that the machines can also act like a humanly. He conducted one test where the machine is in one room and the interrogator is in another room, I can say. In another room, both the machine and interrogator are in different rooms. When the interrogator started asking the questionnaires to the machine which is in another room, the machine started responding to the interrogator. And there is an illusion that even though the machine is responding from the other end, but actually the illusion has been drawn that as if there is some human being who is going to act, giving you the response from the other end. Therefore, this is a famous test that has been cognitive test, I can say, or a cognitive test which has been conducted by the Alan Turing in order to prove that the machines can act humanly in 1950s. That thinking humanly or a cognitive modeling approach here, as I already mentioned, there are so many and do some task here. Even if you ask any person or a baby or some person also to do the task here, they will not directly jump into the task and do the task, right? They will start thinking how to solve this particular task which has been assigned to me, or happens in the human brain here. Therefore, thinking the way is going to strike so many neuron cells. Therefore, accordingly, each and every neuron cell which is activating in the brain will lead to some conclusion. Means we are drawing some new conclusion. Yes, okay, this can be solved in this way, like this, like this, like this. Therefore, in order to do that task, certain timeline is required to carry out that task and reach the goal. Example, one of the machine called as a general problem solver has been designed by the Naval and Seamen in 1961, where it used to solve the problems, whatever the human thinks and minds are going to think and solve the problems. The solution to the problems can be put into the form of a programming, and this general problem solver is going to solve the problems correctly. Correctly, it is solving those problems, I can say, whatever it has been given as. For example, general problem. Say, for example, it may be some of n numbers may be there. The n numbers may be any numbers. It can be a real number, floating point numbers. Even the characters can also be added here. Like this, generalizing general problem solver, which solves the problem on a generic diet, I can say. That is the rationality, thinking rationality. That is as we are we are going to see to a thinking capability as when you think and try to solve a problem, whether all the thinking are a right thinking. That is another important criteria. Yes, I'll solve the problem. I'll think and I'll try to solve the problem. Whether what thinking I done and I use that approach to solve the problem is a right approach. Whatever the thought process have been put up to solve the problem is a right thought to solve the problem, or sometimes it might be a wrong thought also to solve the problem. Therefore, thinking rationally in the rationality, when you add the rationality to the thinking, it means that whatever we'll do always is right here. Therefore, in order to test this, the Greek philosopher called as an Aristotle, he has been formed so many patterns which are purely based on the laws of suggestions. Everyone knows that in a mathematical logic there are laws of predicate logic is there, laws of propositional logic, or rules we are writing down in the exam. rules of inferences. Therefore, all those rules of inferences can be added to the machine, I can say, and in order to draw the right conclusion. Therefore, this approach where we are going to represent each and every task in the form of rules of logic, where we are using a loss of inference, propositional logic, predicate logic, represent that in the form of a logic, whatever you want to do and solve the problem should be represented in the form of logic. And all those logics, when you represent in the form of logic, for example, Socrates is a man, all men are mortal. Therefore, Socrates is a mortal. That is the conclusion drawn. Therefore, this can be represented. For example, this is a simple sentence or in a natural language like an English here, where we can represent in a machine in the form of a prepositional logic and a predicate logic. And in the mathematics, everyone knows this. In a mathematical logic, how to represent these things. Therefore, once we represent it in the logical representation, the machine understands them. And when we apply all those rules of logic, say what would be a rules of logic? For example, I'll tell A is equal to B is equal to C. What does this? A equals to B equals to C means then I can draw certain conclusion based on the laws of transitive law. What is the transitive law is? When A equals to B equals to C, A must be equal to C. That is the transitive law. Like this, we have some predefined set of syllogisms as well as a laws of logic and logic that can be applied over the logical representation of the facts, what you are being represented in the knowledge base. Then we can draw the right conclusion. Whatever you will draw the conclusions by applying these laws of logic and inference rules as well as the mechanisms, inference mechanisms, the conclusions drawn will be a right conclusions only. We cannot have a wrong conclusion. So the thinking is in the right direction when we apply the inference mechanisms or of course, my agent which has been deployed in my classroom is exactly doing the right thing what my professor does. Therefore, it is acting like a human, but it is acting like my professor, and it is delivering all the contents in a right way. Sometimes my professor may also go in a wrong way also, but the agent will not go in a wrong way. The agent will always does the right thing because it has been trained based on the past experience to draw to conclude correctly, and whatever the inferences or mechanisms applied to that, it is addition to that, I can say. Addition more on the drawing the right conclusions here. Therefore, this whatever the agent which is acting like a professor in a classroom definitely delivers all the contents properly, rightly, correctly, because it has been trained in such a way that it should deliver correctly to the children. Therefore, whatever the agent, teacher agent or agent which is going to teach the students in the classroom is already been tested several times whether it is performing well or not. Finally, it has been deployed in a classroom environment. Yes, of course, because
excuse me, sir.
Experience testing what has been done. Yes.
Sir, again the same issues. A lot of members are telling the voice is not clear. Please, can you check the network, sir?
I think from your end, I'm getting a very okay. Now I removed this headphone. Can you check now? Hello.
Yeah, it is.
Now
good,
it is
sir.
audible, sir.
It is audible,
okay,
sir.
I removed the. Yeah, I removed the mic itself. Directly, I'm talking to the this.
Yeah, that's better, sir.
Oh, okay, fine. If anything is there, let me know, sir, so that we will correct it. Okay.
Sure, sir. Yeah, sure.
This is a thing. Okay, thank you. No, this is acting rationally. When we act rationally, what is happening? Yes, whatever the conclusions are being drawn, whatever the agent that has been deployed in that particular environment based on the past experience, so that it will do the right things here. This is how it has been done. Next is intelligent agents. What does an agent? So we'll always talk about the agent. What does an agent? Yes, agent is nothing. It sees from an environment what are the surrounding things are there in the environment and act according to the surrounding environment here. Therefore, even a normal human being also, something I want to do a task in the environment. Let us say I want to write something on in the classroom with the help of a chalk. Therefore, I need to take the chalk piece in my hand and start writing and start delivering the contents to the classroom. Therefore, through my sensors and actuators, I'll do the task here. Therefore, in that classroom environment, what would be a sensors that can take up the inputs? My hand itself is a input here, where it is going to pick up the chalk piece. Yes. Then after that, delivering the contents to my
Devaja,
that is a mouth where. Yeah.
Sir, again the same issues. I think there is some issues with the network from your side. Sorry, sir. Don't mind. So I think there is some issues with the network.
I don't know. I connected, but I'm not showing anything here.
Is it possible
But you
to
are
change? Otherwise, can you change the picture if you don't mind?
Yeah, just a minute. Once again, I plugged in this.
But now it is clear. But once you start presenting the thing, then we are finding the issues.
Okay. I don't know. Yes, sir. I'll go a little bit slow. I think if it is, I think what jerk sequence it is coming.
Yeah, now it is fine. But while presenting, once again, it is breaking. That's why I told like that. Sorry for disturbing you.
Okay. Okay, intelligent agents. What is an intelligent agent? Here, agent is nothing but a device, I can say, which normally collects things from the environment and act on the environment accordingly. Therefore, when you take a normal human as an agent, what could be a sensor organs? Their eyes, ears, and other organs are the sensor organs. And what could be an effect task where we are going to perform a task, where we are going to do the task in the particular surrounding environment through the help of our hands, legs, mouth, and other body parts of the normal human being will be an effectors in that particular environment. If you take a robotic agent, yes, of course, in a robotic agent, it doesn't have a hands, legs, body parts, eyes, yes. But in order to mimic like a human agent, we do have cameras as well as infrared range finders for the sensors, which will help us to take the inputs. You can say several motors will be connected for the robotic agent, which will act as an effect task. Now, the software. What is the software agent? It is nothing but a code or a piece of code, I can say, in terms of a bit strings, which is embedded in some hardware, and it will perform accordingly. Therefore, the software agent example is your washing machines, where it is going to perform because the entire software is embedded in some chip or a board here. Therefore, according to the instructions given by the person who is operating the washing machine, accordingly the task will be done by the particular machine here. This is about an intelligent agent. So this is a structure of an intelligent agent, which gives you the what is an environment it can adopt. See, the environment can be any environment, and in every environment it requires a certain types of sensors, as well as again actuators are required in order to perform the task back into that environment. Therefore, the percept is nothing but a sequence of inputs, what it is receiving from the environment, and the actions are normally actions are nothing but effect that normally they are performed with the help of effectors, which are supported by that particular agent here. The agent function normally maps the percepts histories, where P is a perception or a history or a past experience, to the actions here, because based on a past experience only we can perform our actions. Therefore, the percept sequence, what I'm going to receive from the environment, one after the other. See, at a time T, there is some cup of coffee on the table in the environment, and I have to drink that cup of coffee. Therefore, the next sequence at the time T2, I will lift the cup of coffee. At the time T3, I will hold it in a hand. Then at the time T3 or T4, I may start drinking the coffee from the cup of coffee and start drinking. Therefore, there may be a lip contact with the cup and a lip here. And at the time T5, we'll start one by just drinking it. Therefore, when at the time T10, again, what happens again with the effect class hand? Again, I'm going to place back that particular cup onto a table. See, on a table, the environment consists of a cup of tea, and the agent's task is to bring the cup of tea and put a back cup onto the table. Therefore, it requires a certain types of sensors and effectors to do the task here. Therefore, just merely having a sensors effectors will not complete, but you require some program, right? Embedded program which can be programmed where the sensor inputs are taken and effectors will be moved accordingly, and the task is completed. Therefore, for that we need to write a piece of code which can do that agent's task, you can say. Therefore, what are the different types of agents here? Whenever you design any type of artificial intelligent agents, we can have a different types of agents. Normally, the agents are classified as table-driven agents, simplex agents, model-based agents, goal-based agent. Table-driven, see, as the name itself is indicating table. When I say a table, in a table, just you take our rows and columns will be their normal table. If you draw any table in a computer representation of a table, that is, it is having certain rows and certain columns. For every row and every column, some data is stored here. If that particular row and a column, if data is there, according to the data, you have to see that and look up that particular row and column and act accordingly. That is nothing but a table-driven agent here. What happens with the table-driven agent? Whatever you need to perform. It means that in a task environment, the entire environment is there. That can be put up in the form of a table here. Means when you take a particular environment, the room, a home environment itself, every room we can say as a 0, comma pixel, 0, comma 1 pixel, 1, 1, 0, 1, 0, 2, 0, 3, 0, 4. Similarly, next row 1, 1, 1, 2, 1, 3, 1, 4. See, these are all the pixels which are representing a particular row, particular environment, and you can represent that what could be there at that 0, 0 position, 1, 1 position, when the agent is that particular position and it is looking up the particular data in the particular row and column of that particular row and column and performs the actions accordingly. What should be a next action? Always decided by the entry in that particular table here. Therefore, this particular agent always looks at the entry in the table and takes the current decision based upon the entry in the table. If the entry in the table at a position 1, 1 tells that go to the kitchen and get a break, then it starts going to the kitchen. That's it. What is that? Because at 1, 1 you have been stored that go to the kitchen. Go to is an action which is stored at a 1, 1 entry in the table. Then the agent is at 1, 1 position on your board. Therefore, when it is in the 1, 1 position in the board, what is the task as to be done with the agent is in 1, 1 position on the board? It is stored in array or a lookup table in the 1, 1. Therefore, you see the entry in the 1, 1. The entry in the 1, 1 is having a go to the kitchen and get a glass of water. Therefore, the agent has to go to the kitchen. Now, go to is an action. That's it. The decision is go to now. Therefore, it will go to. This is about your table-driven agent. Looking at the table. And what happens here? Enough memory is required because you're storing in the form of table now each and every action, because the entire environment consists of so many pixels and so much data is to be known. Therefore, the rows and columns will increase their memory is requirement, memory constraint is there here. Therefore, what has to be done? Everything is there in the table itself. You have to see the table in turn has to be stored in another device. Therefore, if the data is there in the table, it will do the action, right? Then I can avoid the using of that table. It's why I should use the table. I don't want to use the table here. When I'm in this particular position, I want to do certain action here. Therefore, I can write all those entries, whatever are done done for that table-driven approach. I can write if that rules in my program itself. If the agent is at 0, 0, 0, 0 position, this action to be done. If the agent is at 0, 1 position, do this action. If the agent is 1, 1 position, I will say let go to the. See, I will not have to store that. I can write all the entries what are there in the table using a simple if rules. If then use rules I can use. Therefore, if the agent is at 1, 1 position, I will write a action rule. I am writing a rule in my table if then else rules. Therefore, if it is at 1, 1, I'll say go to. Therefore, no need to store anything in the table form. Everything I'm writing in the form of rules only. Directly I'll say go to. No need to fetch the data from the table. Unnecessary, it is a wastage of memory, right? And in both the cases, the entire environment is not observable. Whether it knows all, see, at any position, agent is there. Agent is currently 1,1 position. It doesn't know about the things what to be done at 2, 2 or 3, 3. It knows only about the current state, and the current state what should be done. Therefore, the entire environment is not observable. It need to be done. Therefore, partially observed environment. It doesn't know about the entire environment here. It knows only about that particular fact here, current fact. Based on the current facts, it does the action here. No previous history is stored here in a simple reflex agent. Example, addition, which is based only on a current situation in both the case.
Excuse me, Devasar.
When it is keep on the sensor which is sending you the data of the room
Excuse me,
temperature.
Devasar.
Yeah.
Sir, can you come near to the mic so that your voice is audible? Once you go back, there is a breaking of the voice. I think
Okay.
there is some connection loss in some points.
Okay, I think to the network there may be a loss. I think yesterday.
I think
Okay.
better you come near to the mic, sir. That's better, I think.
Yeah. I'm near to the mic now, sir.
Yeah.
I'm very
Sorry, sir.
near to the
Sorry for disturbing.
Okay, no, not an issue, sir. This is how the agent has to act according to the if then else rules. Therefore, if the room temperature is greater than 45 degrees, because the sensor inputs always providing us the data that what is temperature at any point of time t, t1, t2, t3. If it is crosses the 45 degree, then directly we see that switch on the AC light. Therefore, that is about your agent, simplex agent, model-based agent. See, the model-based agent as itself is name itself is indicating entire model or a history or a current world state is stored here. What is the state here? Description of the current world state. The model state of the state of the world, which is nothing but how the world is evolving over a period of time. Whenever you perform certain actions here, see what are the actions you are going to perform into the environment, and when you do perform certain actions, based on the actions, the environment is going to evolve, right? Therefore, how the current state is going to change. Therefore, that history is also kept. Is also kept track. We are going to track that history in a model-based agent. A model is nothing but whenever actions are going to perform into that environment, even the environmental testers are not here, but when you do that particular action into the environment and how the current world is evolving, how it changes, that state is also retained here, and accordingly will perform the next action again. Next action based on the current state. Therefore, the model is going to perform a task, and accordingly every time the current state is being updated here. That is called as a model-based agent, where always the current state is going to evolve. This means it is changing. It changes the state. The model is going to change its current state based on the actions performed. And history, entire history you need to keep, because always the next state in the action is based on a current state only. In such environments, we can change the current states here. Then goal-based agents, the goal-based agents which are similar to the model-based agents, but additional capabilities are added. That is something about planning and searching here. Therefore, it plans and searches the entire environment, and whichever the suitable plan is there in order to reach the goal, accordingly it will perform the actions into the environment. For example, let us take a driver agent. A driver agent. The driver agent is going to take the passenger in a car to some place X, I can say. Then when it is taking to a place X, says target or a goal state. And therefore, this is a goal-based agent. There is a goal where the passenger has told, you have to take me to this particular place, and as it is making the decisions from one step to another step, means from every cross it is going, okay, go to fourth cross, fifth cross, like this it has to move. Then after that, what happens? It takes the decision at every step and it plans accordingly and reaches. That is a goal-based agent here. Okay? The planning has to be done over a path and search what are the different paths are there and take the suitable decisions accordingly so that it can reach to a particular destination, I can say. Now, the last one is utility-based agents, which are similar to the what you call as a goal-based agent. But what happens in a goal-based agent? Yes, both agents are targeting for a goal state. What is a goal achieve? But the agent's the passenger's happiness is not taken into consideration in the goal-based agent. What happens in a goal-based? Yes, it has to take to the desired goal of the passenger. But when the driver agent is taking the passenger in at some point, some place in the middle where an accident has been occurred, but the agent, now this driver agent will not because there's planned in that path, it is going in that path until the path get cleared, it will be stuck there only. Then the passenger might not reach the destination on time because he's having the interview at 10 o'clock in the morning, but he has left his home at 9:15, and by the 9:40 he should be there at the interview point here. But due to the some busy traffic in the middle, or some accident happen on the road somewhere in the middle point, the goal-based agent has been stuck there only because it doesn't have an alternate way or to choose so that it can make the customer happy. That particular thing is not taken into consideration because if the goal is to reach, how we don't know, either it may be a one day, half an hour or 1 hour, 2 hour late, whatever it is, because path it has been selected, it won't change the path. Therefore, utility-based agent, they think effectively. What they will do in the meantime, whenever such things happens in the middle, they will see how to make the customer or a passenger happy. I can take an alternative path, alternative decision, so that I can reach the desired goal of the passenger on time, and without any accidents, as well as safely I can take the passenger within a time itself. Therefore, so that the passenger will become happy even in the something happens in the middle, but the driver agent as planned accordingly changed the plan at that point, and it took to the destination. So now the customer become unhappy. Therefore, it is going to use a utility function in what way I can make the customer happy. With certain techniques it can use. What are the other we call them as such functions as an utility map functions, where we can make the degree of happiness of the goal can be achieved, so the customer isn't happy. Then learning agents, yes, of course, whenever we do do any task in the environment, the performance should increase. Therefore, the learning agents, which is going to evaluate what is the current world state based on the sensor inputs and the past experience or past history. It gives that past history as a feedback to the current state, and the current learning element state can be updated accordingly. The rules or whatever you require, all the changes can be performed in the current state, so that the performance of the learning agent improves and solves problems in a better way. Therefore, you need to change the overall performance of the agent has to be modified in a database accordingly, so that the goal has been reached with a full effect, efficiently, like that, and with accuracy. Then, okay, what could be in different environment types where the agents are going to perform the actions? As I already mentioned, different environments may be there. Because when you put a deploy an agent in any particular point, and what is there at this 1,1 position, what is there at 1,5 position, what is there at 50 position. Therefore, if it is seeing the entire environment, what are the changes in the environment at any particular point of time, at any point of time also, it knows about the entire environment state, how the world is evolving, and how the current state is changing, what the next action to be. Entire thing it knows here. Where the obstacle is there, for example, driving agent itself, it takes where the obstacle comes, at what point the obstacle is there, and out then it can take a good decisions also. Therefore, the environment types, we can have either a fully observable environment, otherwise something is known, something is not known in that environment. What are the difference? We know what would be a right action, next action. Based on a current state or a current input configuration, the agent knows that what could be our next then it can be an episodic environment or a sequential environment. Means episodic means perform this past history, because in the past history, several tasks have been done. Therefore, after this has done this. After this has been done. Like this, all these are nothing but good episodes here. The history will give us the episode where the next decision, what could be done, can be taken by the agent here. Otherwise, it could be a sequence, one after the other. They are linked to each other. Therefore, only when this action is done, then the next action will be taken into consideration. Then we can have the another environment types. It can be a static or a dynamic environment. Static environment, where the environmental parameters as well as the status of the environment will not change. We are not changing anything in the particular environment. For example, if you take a room environment itself, and if I deploy some agent in my house and environment for doing some tasks here, it knows where is the kitchen, where is a bedroom, where is a washing machine, where is the refrigerator. It knows everything because the positions we are not changing. If often the positions are changed, then we cannot. We have to fill the again agent where the in what position what things are there, so that it can do the task accordingly. At all. Whereas in a dynamic environment, what happens, or at any point of time, or as a it is going on changing here. That is called as a dynamic environment. In both the cases, the performance of the agent will depend upon the how far it is going to sense the items, or how far it is going to sense the environment here. Therefore, this next another way is discrete and continuous environment. Here, where discrete is a limited number of distinct, clearly defined percepts and actions. How do we represent and abstract the model of for example, chess is a discrete environment. We know that we know what could be a number of possible moves on each turn here. That is known to us. That is a fixed moves are there for every movement. That is called as a discrete example of a discrete environment. Is our chess environment, I can say, wherein each possible move, each action is having a certain set of possible moves. Only those moves need to be performed here. Then taxi driving environment is a continuous, because the speed and the location of the taxi driver and other vehicles, at what speed they are coming to in opposite direction, that is going to is a continuous. It is changing here. Sometimes maybe more or less. The speed also can be more or less. This is a role of continuous environment. Continuously, the speed needs to be applied in order to reach the destination like that. Then we can have a single agent or a multi-agent environment. Or single agent is only one agent is there in the entire environment, and itself has to do the task in the environment. Multi-agent environment, where more than one agent will be there. Therefore, all these agents will connect to each other. They will collaborate with each other. They will have an interaction with each other. Finally, they will improve the performance of the overall task that has to be done by close coordination with one another in a multi-agent environment types here, so that the goal can be achieved here. Okay, this is about the so far what have been discussed is about artificial intelligence and how the artificial intelligence agents can be behave, and what are the different types of agents can be there, which can be deployed in a variety of environments. What are the types of environments where we can deploy the artificial intelligence agents here. Next, we will move on to the next interesting topic called as a natural language process. Natural, another one is language, another one is a processing here. Therefore, naturally, what you want to process, whatever real world naturally, they have to be ability of the computers to analyze, understand, and generate a human language, including speech. Therefore, with the with respect to the today's Indian scenario, if you consider in an Indian scenario, what happens here is India is a multilingual world here. Why multicultural? Because people across Indian culture will talk using the different languages. Then, in order to understand all these natural languages, where the people are going to talk with each other day-to-day life in order to complete a task. Now, it becomes a very particular language. Then after that, we need to have a communication with several people in that particular global space and do the task. Then we can put our task, how the task can be performed here. Therefore, normally, what could be an input to the natural language processing system? It can be a speech also. Sometimes this is a voice, or it can be a text-based also. Not only a speech can be an input for processing. It can also be a text-based input. Whatever we talk nowadays, hundreds of languages, all those hundreds of languages can be. It can also take text-based inputs of those corresponding language. Even you can have a Kannada language, Kannada written text as an input, or English, or Tamil. Okay, that can be either in a written form or they can be in a speech or signal form. Yeah. Therefore, we can use these things in a different way. Different inputs can be given for a computer program which can understand human language either as it is spoken here. Therefore, NLP is a component of artificial intelligence. And it is useful in several applications here. To name one or two, I put here where the information you want to retrieve, either the information can be structured or unstructured data from an organization, you want to retrieve it. Therefore, what you want to retrieve, the retrieval so that you can start searching the required information over that huge amount of information which is stored in an organization, either as a structured manner or an unstructured manner. Then opinion mining, you can also get an information about a certain product, whether the product is a good or not, by taking the inputs from customers who are going to use that particular product. I can say even in the public domains, we can get feedback about the products, either it may be through social media, such as Facebook, Twitter, etc. Even in Amazon, where several products are being sold daily, every day. Therefore, the feedback whether that is a particular product is a good or a bad. You can also recommend that to some other people where that product is a good or a bad, like that. Therefore, based on textual inputs which are being given on social media by the various customers who are being used by that particular product, they can now based on the input which is in the form of text, what have been given on the social medias, that can be fetched from the natural language processing system, and it can do certain analysis on that textual data, and finally it can predict the what you call as the opinion of that particular product here. Therefore, what is the machine learning comes to picture on a based on only on a past experience only, we can predict something. That is about machine learning, because NLP and machine learning normally go in hand here. Even a machine learning technique can also be applied in NLP in order to draw certain conclusions, such as in opinion mining, because where the past experiences of the users, where they are given recommendations of the product, they can be collected, and accordingly the decisions or predictions can be taken into consideration. Machine learning, see, as I mentioned, it always takes a decision by observing a past experience. Without a past experience, ML algorithms will not be able to predict anything intelligently on a specific task here. Therefore, only if the past experience is there, then the future predictions can be done. Otherwise, it is difficult to do the future predictions by applying the ML in a NLP. Even you can apply the ML machine learning techniques in NLP. Therefore, these both are all what I call as an NLP as well as machine learning and the agent-based techniques all are nothing but a part of an artificial intelligence here. Okay, as I already mentioned, Indian culture, there are several people across the in India where they are going to talk in a different languages. Therefore, we require such machines which can understand and process such languages, and they can generate generate the understanding back to the user. Suppose I'm talking in a Kannada, I can understand, the other person can understand only in a Hindi. Then yes, there should be some machine which can, of course, understand the Kannada, represent the Kannada, generate the equivalent representations in Hindi, and speak out the Hindi language, so that the other end person can understand the Hindi language here. Therefore, this is how where the machines will require, so that they can exhibit the intelligent behavior with the help of natural language processing tools or natural language processing techniques, I can say. Okay. As I mentioned here, AI is nothing but building the agents that do the right things. NLP is building the systems that understand language, which is a subset of AI. ML is from a past experience. Yes, it is also a subset of AI. Both NLP and ML can be combined together so that the learning experience of the machines about the language will increase and predicts the intelligent behavior, predict the intelligent behavior, so that it will be useful across the society. So why require a natural language processing? If you go into a why question, we know that the data is either it can be a structured data or a more unstructured data, because in our organizations we may also store a structured information, but when you come to our internet, because today's world every day or something or other thing which is being putting every day billions or millions of information will be stored on the internet here. Internet is a huge collection of data here. Well, there are even for not only 4 billion or trillion or etc. I can say so much pages of information is available on the internet, and whatever the data is available on the internet is an unstructured data. Don't have any structured data, which is normally an unstructured data here. Therefore, you want to have a search something which is there on the internet. Let us say that I want to search all the public papers which are based on a natural language processing itself. Therefore, in that case, if you start searching over the internet about the NLP, you may get hundreds or thousands of documents which are relevant documents. How do you find it? Therefore, we need some processing techniques which can process the language. What you are given as an input is an English language to search that. Yes, of course, it searches those texts and classify the text into the categories. All NLP will be put into some category and they will be displayed. Therefore, the searching normally, if you go for a Google or a Bing, several other search websites, they will Google how it searches. Google's page ranking algorithm, which ranks pages which are relevant to the NLP keyword, and they will be on the top 50 or top 20 will be there. Therefore, the first page which displays now all top 20 links, what is going to be provided will be the relevant links like that. Therefore, the indexing and the page ranking mechanisms will be adopted by the search engines, where they are going to use these NLP techniques only. This every keyword, the NLP, how many times this particular NLP has been appeared in this particular document. If the frequency of that NLP text, natural language processing text, is more in this document, then the document ranking of this frequency or ranking of this particular word is more in this document, so that this document can be a more relevant to me. Therefore, what the Google search engine will do, since the page ranking of this particular page is high, it will be put at the top of the search like that. No, first it will be first in the search like that. Therefore, that is about how the processing, why the natural language processing is needed. Even in automatic translation, what I told just now, that is, I'm talking in the Kannada, the person may understand only Hindi. Therefore, we may require translators, language translators, which translate from one language to another language. Even a speech understanding also. Not only automatic translation works across a voice or a speech, across a text also it works here. Therefore, the conversation has to be understood by the other end person in an elegant manner. Therefore, we require translator systems here. Where the lateral language processing plays significant role, I can say. Okay. The information extraction. You want to extract any useful information from resumes. Example. This is the example where you want to extract all the resumes which are fit for this particular job based on the job roles or job designations or job qualifications. I can say we can sort out all texts. Therefore, again, it is again you are finding out all the resumes which are matching based on your qualification may be there or based on the domain expertise may be there. Like this, we are going to sort out all. Earlier, the machine or humans are going to do the same task can be done by the machines. Where nowadays all the what you call as resume builders or HRs, they are going to use such information extraction tools. They are going to use online tools, facilities available, where they are going to segregate all the resumes based on the what you call as domain expertise may be there, qualifications may be there, etc. Then automatic summarization, where automatic summarization, suppose let us say as I will see 10 movies. If I see 10 movies, what is the summary of that movie, each movie? I want to do that. That is called as an automatic summarization. Another way is if I read 10 documents, let us say, or if I read 10 textbooks, let us say, I want to have a summary of each of those textbooks, I can say. If there is a summary, what is being described in that those 10 textbooks, the next time a particular textbook or not. Therefore, automatic summary generation. If we generate a summary, either it can be a book may be there, text based may be there, or it can be a summary of an entire movie may be there. Like this, anything else you want, you can apply this summarization to anything. Therefore, when you have a summary of that particular 10 textbooks, next time when any user comes, he can make a decision that whether or not to buy a book based on a summary. He did not have to read the entire textbook. Only he reads the summary of one paragraph that has been written, and that is generated by our natural language processing tool, so that he will come to a conclusion. Yes, I can buy or not, like that. Therefore, knowledge acquisition. Yes, the knowledge representation is one of the important tool where we can represent whatever, as I already mentioned, logic programming as well as the predicate logic. In terms of logic, we can represent the knowledge in a knowledge base here. Whatever the things are there, for example, day-to-day, whatever the textbook information is there, name, author, all those information, we can also represent in the form of database, right? Therefore, if there is the database of all the books information, then we can retrieve all the books which are required for the relevant to the NLP, right? If there is no knowledge base, you are not having any knowledge or knowledge base or a database in general, we can say, compare with our traditional RDBMS techniques, where you're representing entire thing in the form of rows and tables and retrieving the particular information from that. Similarly, you need to represent the knowledge of textual information in the form of using the natural language processing tools and extract the information whatever it is required. Accordingly, you need to write the query. Same thing. Then text generation and dialogues. Yes, of course, you can generate the text which is required here. Because after processing the information which is stored in the knowledge base, of course, some text has been generated. Either that what the text has been generated, it can be a summary of those 10 books, or it can be a summary of your movie, right? These things are there. So this is where we can apply these NLP techniques in order to process a vast variety of information across a globe here. Then when you come compared to the traditional languages like a C and C++, where the rules are there, compilation rules are there, we don't have any such rules in the natural language. Even though if I tell that, okay, Tom, go to school, everyone will understand because it is clearly understand, but there is no syntactic, there may be a grammatical mistake in telling this natural language. sentence. But if you miss a semicolon or comma or dot anything in your formal languages or artificial languages like a C or a C++, you will get an error. Okay, compilation error you will get there. Syntax error will get. Therefore, natural language, what happens while communicating in the natural language day to day, what the people in the society are going to speak is, of course, there is no one checks the grammar of that, right? When we speak continuously to another person, yes, of course, he will understand. There may be a grammatical mistake. Such example is Tom go to school. Actually, I should tell us Tom goes to school, But even I'm telling it Tom go to school, it means that it is very well and clearly and understood here, right? Therefore, such small grammatical, such things, errors are not taken into consideration by natural language processing system. The system must understand that because there is a morphological change here. Tom go to school is same as Tom goes to school only. Our machines should understand as the normal human beings are going to understand. Now, let us take this an example. What is this written on the 4 lines? So the first bullet points here. If I ask anyone, okay, what is this KJ? I can tell that it is KJ, MFFF, MEVV like that. But I cannot tell what is exactly the meaning of these first 5 bullet points. What is there on the slide here? Because I don't know this particular language. Because from my birth or a childhood, I have not seen this particular language. But I have learned ABCD English alphabets. That is, I'm telling letter by letter that it is COOVELE 2 caps EK. Like this I can tell. But what is the meaning of these first 5 bullet points? What is there on the screen? Nobody knows that. Correct? I cannot interpret because I don't know. I don't have that information. Even in the similar way, if you give this to the natural language system, which doesn't have that information, how it can tell? Therefore, unless we learn this particular, there may be a specific significant meaning in some tribal languages. Therefore, when there is a significant meaning in a tribal language, when the people who have been read such language, they can understand this because they have been trained from the birth and they know this language also. And another way I can say that the person who is in the North India, he knows about a Hindi and he can read the Hindi. Who is in the South India, he knows about let us say as a Kannada in Karnataka. Kannada is known to everyone. Therefore, if you put something on a Kannada, I read Kannada, those languages will be understood and I can read and I can understand. And so, if you put me Hindi because I don't know about Hindi, right? From that I am not studying the Hindi language, I don't know how to communicate. Then it becomes a difficult because I am not trained in Hindi. The same thing happens in the machines also. Unless we teach them, because computers will not understand anything unless you are going to give us some knowledge to them. Therefore, they lack. It is merely a box. You should give the knowledge to them. Therefore, what the computers will have no trouble in understanding. People will have no trouble in understanding the language because they have the common sense, knowledge, reasoning capacity, experience. Because only those who have the knowledge about that previous text. If you don't have a knowledge about that text, then you cannot understand that. Therefore, without a common sense as well as the reasoning capability, the computers cannot reason and tell you what is there or what is the given input to it. That is the thing here. Unless we teach anything to the computer system, it won't tell us or it won't reason and it won't give you the conclusions. Therefore, always it is required that whatever you want to do a task related to the task, all the data has to be given as an input to the computer. Then only it learns, it senses the information, it reasons the information, it has got experience over that information, then it can predict and tell you something. Otherwise, it's not possible here. Due to a lack of knowledge, it's possible anything. Therefore, as I already mentioned, while the natural language processing, it can be used for information retrieval, machine translation, language analysis. Analyze whatever the input is given at the static as well as at the semantic level. You need to be understand the data. Okay. Then the field of the NLP, which normally is evolving in the current trend over a period of time. So what is an input that can be given to an NLP system, and what could be an output from an NLP system as opposed to the artificial languages? Therefore, what can be an input? It can be either speech or a written text. Similarly, output can be, as I already mentioned, it can be a speech or a written text can be an output also. Therefore, always the input is given in the form of speech or a signal, or the output is also in the form of a speech or a signal or a text can be there. Similarly, if I do an input in the form of a text, again the output can be either a text or it can be a speech signal, I can say. Therefore, now we'll come into what could be a components of the NLP so that it can process the corresponding inputs. There are two main important components of the NLP. One is NLU, we can say as natural language understanding, and another one is a natural language generation. See, what is natural language understanding? Mapping whatever the input you are given in the form of a natural language into a useful representations of a computer, analyzing different aspects of the language. Suppose if I do a Kannada as an input to text, yes, of course, my machine should understand all the parts of this Kannada. Because even in English, if I do, yes, it should understand the English statements, whatever you have been given. Therefore, my system, natural understanding component, it should understand all the literals which are given in English language, all the words of the English language, added into individual components, and those components should be represented in a system in some useful notations. That is called as a natural language understanding. Understanding is whatever you do the input, it should be broken up into small pieces, and so that it can be represented in a computer representation, so that it can transform into some other representations. Right? English, if you represent in a computer way, so that you can transform it in another way also, another language. Therefore, natural language generating, that is nothing but the energy. Suppose Kannada, whatever English to Hindi, if I want, if I tell how are you, everything is represented in a computer. Then how are you should be translated into finding what could be a equivalent word of how in Hindi, are in Hindi, how are you, miss, how are you, all these three words or components are there, or words should be mapped to the corresponding words in a Hindi language. Then after that, you got the corresponding words of the Hindi language. Try to combine these words of the Hindi language and form a sentences, so that the syntactically the sentence is correct, and when you output that sentence, the syntactic as well as the meaning of the sentence should also not change in the target language, Hindi language. Therefore, it is the process of producing meaningful phrases and sentences in the form of natural. Some other internal representation again. This is about the understanding and generation. Whatever you understand should be generated here. Therefore, the generation part, it includes these tasks here. One is text planning and sentence planning, text realization. What I told example here is text planning here includes retrieving the relevant content from the knowledge base. Therefore, whenever you want to generate the English to a Hindi language, therefore you need to find out the relevant words which are suiting to each words. That is called as text planning. Next is you need to combine all those Hindi words to form a well-formed sentence, meaningful sentences, right? Combining all those words, that's called a sentence planning. It may be matched with 3 to 4 Hindi words. Therefore, all those 3 to 4 Hindi words which have been chosen in a Hindi language, correct it is. Therefore, text realization is nothing but a sentence planning, a sentence structure. That is an example. We have a sentence for a sentence in English like sentences. There are some rules are governing which to form a sentences. Combining the sentences, there are certain rules are there in English grammar. This is part of speech grammar. Subject should be followed with a predicate. And again, what could be a predicate? It can be a noun or a pronoun. What could be a noun phrase followed with a verb phrase. Again, verb phrase can be a verb followed with a prepositional phrase. Like this, there are certain rules which are being governed in forming the sentence structure in the English language. Similarly, we need to map those whatever the combined sentences. This is where it is realizing. It is where it is the harder here. Understanding is harder than generating it. First thing is you need to understand. You need to understand the language and then find out the corresponding and combining. That becomes easier. Generating is easier, but understanding. If you understand the meaning, because in a different way, then the meaning of the sentence, the actual meaning, or in a original input sentence may become a different in another language also. Therefore, understanding plays a very significant role. Understanding is harder when compared to the representations generation. Then I will see about some of the difficulties which are encountered in NLP, NLU, that natural language. There are various levels of ambiguities, because whenever you want to understand anything in any language, I need to understand the literals of the Hindi alphabet, say what are they, how to write, and what are the kagunikas in that particular language. When you understand all those things in that particular language, then you can understand the words in the language, and you will start learning the combining those words in the language to form a sentences. And when you are combining those words in a language to form a well-defined sentence structure, there may be some difficulties will occur here, right? Therefore, what would be a difficulties in understanding those understanding the language here? Lexical ambiguity, it is at a primitive level, such as a word board as whether it can be used as a noun or a verb here. There is a difficulty, because you may be tagging that this particular word board can be a noun or a verb. How to tag it? It becomes a word level ambiguity. Lexical level ambiguity is a word level ambiguity. Every word may have different meanings. Sometimes it can have more than one meaning also. Whenever there is a more than one meaning, whether to tag it to a noun, a verb, because there are parts of speech of the grammar, English grammar, if you consider noun, pronoun, adverb, adjective, exclamatory sentence, interrogative sentence, like this, so many are there. If you are tagging that particular word, what should be tagged? Whether it should be tagged as a noun, adjective, or a verb, because it may be part of a noun also, verb also. That is an ambiguity. Then syntax level ambiguity, when you combine all those words to form a sentences, and what could be a meaning of that sentence. For example, he lifted the beetle with a red cap. See, he lifted the beetle with a red cap. It means that whether the he used the cap to lift the red cap. There are two interpretations here: whether lifting the beetle with the help of using the cap, or he lifted the beetle with a red cap. This is another at a sentence level. It can have two different meanings here. In that case, it becomes difficult. That is called sentence level ambiguity. Referential ambiguity, where sometimes the next sentence may be purely depend upon the previous sentences also. Therefore, when it is depending on the previous sentences, whether the particular verb will be belonging to whom here. For example, let us say Rima went to a Gauri. She said, "I am tired." Now here, what is it? I am. Who is I am here? Who is tired? I am tired. Whether Gauri is tired or Rima is tired, again there is a question mark here. Whether I am is referring to a Rima or a Gauri. This is called as referential ambiguity while using the pronouns. Sometimes happens here. Therefore, the one input can mean a different meanings here. Many inputs can mean a same meaning also something. This should be taken into utmost care. Therefore, what are the steps or NLP terminologies associated here is some important terminologies one has to know here. One is phonology. What is phonology? Is but a sound. How the letters should be pronounced in a systematic way here. Dog. See, there is only a one letter difference here. Dog and daughter. Sometimes when we say as a dot, someone may be heard as a got like that, goat or a got like this, something else. The pronunciation should be clear. Otherwise, the letter may have a different meaning here, because one letter change will change its entire meaning. Now, morphology, there is a change in the word structure here. Say books. Book is a singular and books is a plural here. Therefore, changing one letter may also change the morphology or structure of that particular word here. The morpheme S is it is going to change to many books like that. And the morpheme is normally a primitive unit of English, any language here. Then syntax, yes, of course, arranging the words, whatever the words are there, in order to form a well-defined syntax. Sometimes they may be syntactically correct, but semantically it may not lead to some meaningful sentences here. Therefore, whenever you are combining the words in order to form a meaningful sentence, and when you read the entire sentence, which is a combination of several words, whether these words, whether the sentence is a meaningful sentence or not, that you need to check it out. The pragmatics, it deals with the understanding and using and understanding the sentences in a different situation, because same sentence can be used in more than one situation. I can use same sentence. A plant. When I say the plant, okay, these plants are very good. It may be some plants, normal plants here, and there may be a plant which we call as a industrial plant. Also, this plant is very high and what you call as it is going to produce so many chemicals like that. Because in that case, the plant is going to refer to the industrial plant. Therefore, that depends upon the context. The pragmatics is nothing but a context or situation, how the words are used. Because every word is having its own meaning in a context here. The context is also very important whenever you are going to analyze something about that word in the context here. Discourse is nothing but how one word is related to another word in a sentences. Because when we talk, we are going to write so many sentences. First sentence followed with the second sentence. Therefore, there may be a relation of some word in the second sentence, which is depending on the first sentence, right? That is the and the interpretation of the meaning of the second sentence is purely depending on the first sentence. That is called as a discourse here. Now, let us have in detail about those issues which occurs in the analyzing the natural language input. Normally, what we take in the taking that input and finding the structure and whether it is a well-formed, semantically correct or not, like that. Let us take an example here. The dog ate my homework, and then if I ask the question, who did what here? Yes, sir. Who did what? Yes, the dog. The dog has ate what? It's my homework here. Yes, of course, syntactically it is correct here. Because when you ask the question, your language translator or NLP system is going to identify correctly the parts of speech and tag each of them correctly. And the PO tagging is about 95 to 95 percentage and above, and can be improved. I can say means it has been tagged correctly here. Therefore, we got a higher percentage accuracy. Now, another example, another issue in syntax, as I already mentioned, the words may have different meaning. For example, let us take a group of words. That is mother-in-law. Mother-in-law. These are all different. Mother is mother. In is different. Law is there may be a law. I can say. Then hot is different and dog is different. When you combine these two, means identifying the collocations is something that when you combine the group of words, they may have some other different meaning also in that particular context or sentence. Therefore, we need to take whether there are any such words combined together and form the sentence here. Mother-in-law is something. It's correct. Then hot dog is some hot food. I can say. Whereas hot is different, dog is different. That is different meaning. Now, another example of issues in the syntax analysis is the shallow parsing. The dog chased the bear. Then, if I ask who chased what, yes, the dog has chased the bear. And normally we use as a subject and predicate here. The subject is in English language. When you take parts of speech and grammar, rules of the grammar, we need to have a subject and a predicate in a sentence. Yes, of course, the subject is the dog, and chased the bear is a predicate in the sentence. Therefore, the subject is nothing but when you take in the form of English. With our files, we see. Therefore, when you write the grammar of that particular sentence, in order to parse the sentences of the English language, you need to write the grammar for a sentence or rules for a grammar rules or rules which are going to accept the sentences of your English language as per the rules and regulations of the parts of speech here. Therefore, noun phrase followed with our phrase. We say sentence may be having a noun phrase followed with our phrase. Noun phrase is nothing. Verb phrase may be a verb followed with a preposition followed with a verb may be there. Like this, if you go into a deep, that is called as a shallow parsing here, where we are going to tag each and everything in the form of parts of speech tagging will be done more efficiently. Now, let us take an example here. John loves a lady. As per the parts of speech and the grammar is there. Let us assume that there is a grammar for a English sentence. Yes, and we are written a compiler. I think you know most of the compilers which are going to compile languages, they have got their own set of rules and regulations. Like similarly, English grammar is governed by English sentences are governed by the rules and regulations of the parts of speech. Therefore, sentence. What is the sentence? Okay, John loves Mary. Therefore, the sentence is having a noun phrase followed with a verb phrase. What is noun phrase? John, and loves Mary is a verb phrase. Again, what is the noun phrase? There is a rule noun phrase is a noun. And what is a noun? It is a John. Then what is the verb phrase? Yes, it is a verb followed with a noun phrase. Verb is loves and noun phrase is Mary. Noun phrase is a noun is a Mary. Therefore, now you can see that when we say this loves here, this is nothing but a full passive syntax analysis of that particular sentence. John loves Mary. Even if I tell as John loves Mary, both the system should understand that love and loves both are same here, because love is a motto. Because in a system, it knows about the word love. It knows what is love meaning. But here, what I given is loves. There is a morphological change, because what the system has understood is lover, but there is a morphological change in the lover as loves. Therefore, both it will automatically understood that yes, this is nothing but a morphological change of the same word love. Therefore, the meaning remains the same. Therefore, this will be easily passed and understood by the machine, even though there is a morphological. Now, another one will take that. Another one, the boy went to school. Suppose the machine knows the intelligent machine, or which is exhibiting the intelligent behavior of NLP, it knows the meaning of go. Go is went is a morphological change of go. Therefore, if you train the machine in such a way that go and went and goes are all are same here. The boy goes to school, the boy went to school, the boy go to school, all are same here. Therefore, this is a morphological change. If it knows about a go, it should also know about a when, goes, everything are same. Therefore, this will be easily understood by the machine because of the morphological change. What I told as some important terminologies that every intelligent machine which is exhibiting the intelligent behavior in order to understand the sentences of the English language. In that case, the morphological changes must be understood here. Go is went is the morphological change of the go itself. Therefore, when I give the boy went to school, it will understand that as the boy has gone to school like that. Went, gone, goes, everything it should understand it. Now, if it is not understanding, then again there is a problem there. If each and every word has to. Also, it should predict the exact meaning, syntax of that particular sentence. Now, what is an anaphora resolution here? The dog entered my room. It scared me. See, what has entered in your room and what has been scared? The dog has scared me, right? Then in the park with a telescope. Yes, what do? You're a person is being seeing the man in the park. It means that what are the different interpretations can be there? If I stress on particular word, we may get a different meanings of this word. For example, that is anaphora resolution. The such things should be clearly handled by your NLP systems. This is problem here. Therefore, I saw the person is seeing the man. There is a man in the park holding the telescope. That is one meaning. Means in the park, the man is holding the telescope. I have seen the man with the telescope in the park. Otherwise, another way is I am seeing the man in the park through the telescope. It may be like this. With the telescope means I am seeing the particular man through the telescope. He is there in the park. This is the second way of interpretation. Therefore, the third way of interpretation, again, it may be a different way. I saw the man in the park with the telescope here. Means the man is holding the particular in the park. In the park, he is holding the telescope here. This is all some interpretations. Means we can have more than one interpretation for the sentence. Such sentences should be handled carefully. This is about the issues, because whenever you are processing the inputs in any language in the text form, there are certain issues because the interpretation meaning of more than one meaning in a particular context. There is an ambiguity, right? Ambiguous. The sentences are ambiguous. We cannot predict the output properly. Therefore, it is very important to understand the structure or syntax of that. Next, once you understand the structure or a syntax, and if there is more than one meaning, how you can resolve that issue, sir? With the help of semantic analysis. See, I told a plant can be industrial plant, or it can be a sea plant, or a living organism plant here. Therefore, both the words are ambiguous. If I say the plant, which plant here, right? Then importance of semantics, which is may lead to a wrong translation, wrong information, wrong reference will happen. Therefore, everything will go wrong there if you are not handle the anaphora resolution, where we can have a same word may have a different meanings in a different context. Then how to learn the meaning of the words. You take some context here. For example, will concentrate plant itself. Now it is a bullet point here. They are producing about 1,000 automobiles in a new plant. When there are 1,000 automobiles in a new plant, now see, this is related to another keyword is that in this automobile. Therefore, this particular new plant should be a plant, industrial plant itself. We can judge here. Now you take a second sentence. The sea flora consists of 1,000 different plant species. See the sea flora, near the sea flora, and it is a plant species. Then it should be a plant which is giving you the normal plants here, plant species like that. Now, if you go for third sentence, the plant was close to the farm of animals. Now again there is an ambiguity, which is this plant here, whether it is a sea flora plant or it may be an automobile plant, which is where there is no. Therefore, something again another few more sentences you require in order to interpret the this meaning of this plant. If you have some more sentence about this, another one or two sentences, then you can get what is this, which plant is close to the farm of animals, whether it is a sea flora or a plant species or it is an industrial plant, you can decide it. Therefore, you need to have, that is nothing but other sentences will have the impact on previous sentences. As I told that whenever you want to judge something, there may be some other sentences which are also having the influence on other sentences. So based on a context, you can have several sentences. You see whether the plant we can interpret the meaning of the plant based on a next upcoming sentences like that. Therefore, when you train only like that plant, if there are 100 samples and you tag all those plants as industrial or a C2 plant like that, you may get an accuracy of up to 60 to 70%. But still, you need to train the algorithms in a more proper way. Tagging should be done for each of those next sentences also. That is what is the next sentence, how it is related. If more the training is there, then the accuracy can be improvised here. Otherwise, what happens? You may not get good accurate results or predictions may go wrong. Lot of information related to the annotated data, that is where you are tagging it as a sea plant or it is an industrial plant like that. You are tagging all those inputs of the sentences. Belongs to the plant in the sentence will belong to a sea plant, or it may be a plant species, or it may be an industrial plant. If you properly annotate it, it's fine. If it is not properly classified, then it means that again you need to enhance your training based on the past experiences. Therefore, in order to improve that, the ML techniques can be applied, where the prediction will be more accurate based on the previous experiences. Okay, issues in information of this. There was a group of age about 8 to 9 people close to an entrance of the highway 75. If I ask the query, who are the people, then 8 to 9 people, then where they are close to the highway 75. Yes, of course, we are extracting the information based on the queries only. But sometimes whatever you extracted the information, based on the extracted information, you want to have a new patterns to be detected. Therefore, 8 to 9 people, highway 75, this is something else. Therefore, based on this something data which have been extracted from that, can be detect new patterns here. Yes, we can detect new patterns with the whatever the questionnaires we got, we'll get a new patterns. Yes, for example, as I mentioned that all the PDF files which relates to the natural language processing, I want to search from hundreds of such mechanical documents, and whether all these documents are related to mine, all these patterns are predicted to my search or not. Based on a frequency or a mapping like this, we can sort at the top 10. Top will be coming on the topmost first in the first preference in the search, which are not relevant will be in the last in the search like that. Therefore, what patterns, and even sometimes we could get a new things here. Not only the information what has been extracted, using that extracted information, we can also predict the new things. New things can be predicted like that. This will happen, as I mentioned here, issues in the information retrieval, because always there may be relevant and irrelevant searches what you search for on the internet. Example, you take the same plant itself. If you want to search about a plant, I may want to search. If you do a search key as only plant, then you may get a plant species or you may get industrial plants. Then another example is I went to the bank to see the sunset. Yes, I went to the bank to see the sunset. It can the bank. I went to the bank. If I tell only this much, which is a bank, either it can be a river bank or it may be a bank with a cash. Correct? If I tell only I went to the bank and search that, which bank it is, any bank can be there. Therefore, if you have some more information, some more additional information, so based on the context, the search can be more precise here. Therefore, the results for a prediction often depends upon the input what you are given, as well as the come about that. I went to the bank with the money. Now this particular bank is a river bank, or because the bank means it can be a river bank or it can be a bank where the cash is deposited. I can get it. Therefore, for this, in order to avoid this, because the analytic processing system should understand this is an institute or a bank, government bank or an organization where the money is there, and I can withdraw a bank. Because from this sentence, I can understand I went to the bank to withdraw money. Therefore, withdraw money. Therefore, the bank is visited by many people to watch the sunset. When it is visited by many people to watch the sunset, it is nothing but a river bank. Then the bank is an institute where it stores the money. Where it is storing the money, then only there I can retrieve the cash. Therefore, this particular I went to the bank to withdraw money. If the system has been semantic net has been drawn and information has been stored with respect to the semantic net, this will be 100%. It will be matching with this. Bank is an institute. This bank will be matching with an institute which stores money, because it is also having the money in the bank. That from here you can withdraw the money. You can conclude that this particular bank is an institute rather. Now, if this particular sentence is not there, if this semantic structure is not represented in a machine, then it could not recognize this bank is a river. It can maybe as a river bank, or it may be a close to a river like this. But since the semantic net is properly represented in a machine, therefore it has a close match with the institute where the money is stored, and we can have a withdrawal of money there. Yeah. Right. Now, a similar issues occurs when you are retrieving the information from across languages. For example, if I search something on a net that what is the minimum age requirement for a car rental in Italy, therefore this the query is given in English language. Therefore, result of the query should be always in English language only. Correct? On a Google research in English, it is used in English language, not other language, right? Therefore, here what is the minimum age in a car for rental? Yes, rental in Italy are mentioning. Therefore, in Italy, there are almost all there may be documents which are in Italian documents only. Therefore, even the query may consist of English documents as well as Italian documents. And again, all these Italian documents need to be converted using a machine translator in English, and combine these English converted Italian documents with the Italian English documents generated, and give the result in English. Finally, query output is again in English. Therefore, you require some translator where it converts the Italian documents to the English documents here. Therefore, that is a use of a machine translator. Then the last is we can also use issues in machine translation, because English to Hindi, Hindi to English, and so many other translators are also required here based upon input and output language. What is the output language prediction required? Similarly, we can have a speech to speech machine translators also. Whenever you are going to convert a speech to speech directly, the speech to speech that is automatic speech recognizer will not convert directly to the speech of that particular language. First, it will convert to the inner text, and that text will be converted to the target language text, and the target language text will be converted to the target language speech like that. See, for example, here in a speech to speech translator, what happens here? Hindi speech is there, H is a Hindi language. The Hindi speech is converted to a Hindi text, target language text, Hindi text. Then there is a machine translator which acts upon this Hindi text, and you will getting a English or a Bengali text again, text only. Machine translator translate one text to another text only. Therefore, here we are going to get a English or in Bengali. Say that English is converted to English speech, or else Bengali is converted to a Bengali speech, I can say. This is how the target speak in one language over my phone. Let us say I will be speaking in a Kannada, then there may be other end who is going to understand in his own native language itself. Say, let us say it will be a Tamil. I go on speaking in Kannada only. He will go on receiving the inputs in at his end he will be listening in Tamil only. And when he spoke in Tamil, and I will be listening in Kannada. Therefore, there will be a translators in the mobile applications where there will be a direct. You will not have to know about the details about the communication about the parts of speech or grammar, how to know the language rules of the other native languages, other district or native language, native place, native languages. No need to worry about that. If the machine helps us to do such translations, definitely sure you can speak in your own native language. The other person can understand in his own native language. Then or vice versa also this happens here. Okay, these are the steps what I already mentioned, that 5 important points. One has to understand your lexical, syntax, semantic, discourse, pragmatic analysis. 5 important parts of terminologies itself are the 5 steps in the NLP process itself. Lexical at a word level, ambiguity should be reduced. Syntax at the sentence level. Semantics, because one sentence may be having one word may have a different meaning in different context. Discourse of integration. Discourse is nothing but it is nothing but the meaning of any sentence may be different in different contexts. The pragmatics were of that particular word in that language, and the one word may depend upon other words also. That whatever we have been seen, all those problems, issues, all those need to be solved at every step of NLP process. Therefore, the entire process is a 5-step process. These processes need to be taken into one after the other. Then normally, how the syntax analysis. This I won't go in detail about this, but when we write a grammar, what I told, the grammar rules has to be written in these grammar rules. The grammar can be supported by using the context-free grammars. We know that we are familiar with the context-free grammar, how to write the CFGs. Similarly, for any grammar, any language you take, each and every language, what you are going to talk about in Indian culture, because India is a multilingual world, most of the languages are spoken in the Indian culture. Each and every language has been governed by their own grammar rules, or parts of speech of that grammar will be there. In English grammar, if you take, there is a sentence will be followed with a noun phrase, followed with a verb phrase. Again, what could be a verb phrase? Verb phrase maybe a noun phrase followed with a verb phrase or a noun phrase, or it can be an article or a determinant or noun, determinant or an adjective. Therefore, how these are all this is an example of something I given, but you can generalize the grammar rules can be written for your entire English statements here. What are all the different words are there? What are all the different nouns are there? What are all the different verbs are there? You can put in a verb like that. What phrase means what, adjective means what. See if any other rules are there, grammar rules. This is just like a sample what I shown on the screen. You can write your own grammar rules for English language, so that finally this particular grammar sentence structure, what you have been written for sentences of your English language, then you can check the ambiguity is there or not. Because if there is the particular sentence is having more than one meaning, it means that the grammar is an ambiguous. When the grammar is an ambiguous, it means that the particular sentence is having more than one meaning here. Therefore, in order to avoid, you should write the grammar in such a way that it should be an unambiguous grammar. This is just highlighting your context-free grammar with respect to the usage of the NLP processor. Therefore, writing the grammar in unambiguous grammar helps us to avoid the interpretations of the sentences. This is an example. The bird picks the grains. This is an example of past tree or which is constructed using the grammar rules. What your sample written there. If you are having only one distinct past tree, it means that whatever the bird picks the grains, it is nothing but it is having only one meaning. If you are having more than one parse tree, then it means that we have a ambiguity in the grammar. Similarly, in order to do the parsing, whether it is done correctly or not, we are having so many parsers. We'll not go in detail about the different types of parsers which are available in the compiler design course as a part of the BTech. Just I highlighted one parser, top-down parser, where it is going to match finding the terminals in the input sentence, whether they are being matched or not, and whether there is a passing error, is there a passing ambiguity, is there. There are different types of parsers also there in order to build a syntax of the syntactic structure of the English language sentence. We have top-down, several top-down parsers are there, canonical, LR parser, LR0 parser, SLR parser is there. See, which is a parser which gives us the correct syntactic structure of the English language statement. We can apply any one of the parser. I see that the structure of that sentence after using this particular parser algorithm is right or not. If it is right, then we can say that whatever the syntactic structure of that particular sentence is correct, and it is treated correctly or not, like that. Okay, I think with this I'll conclude my session. Hello. Hello.
Yes, sir. Sir, am I audible, sir?
With this I have been. Yes, audible, ma'am.
Sir, we have some questions from the audience. So can you see the chat, sir? Private chat.
Private chat means again I should off this mode. Come back to. Yeah. Suggest me some tips in encoding text which are mixed with two language encoding text. Yes, we can use encoders encoding text which are mixed with two languages. Normally, we cannot encode two language, but there are some encoders where they're supporting more than one language at a time. Two languages cannot be given as an input, but we have to do one by one language to be taken into consideration. Then you can combine the two languages into one. That you can have a look over that. Then character level encoding versus word level. Yes, character level is nothing but it is a one character we are going to encoding. But which is best preferable? Yes, I think word level. Yes, there may be a certain ambiguity word level. But if you go at the deeper level, more deeper level at the character level, I think you may get more clear predictions. Yes, how to annotate the text data if it is framed by ourselves. Yeah, okay. You want to if you are building your own text data, in that case, you need to annotate how you are going to annotate. Say you give an entire input, then you need to have one table here, Excel file or like that. Then you annotate whether this belongs to this belongs to this, belongs to this. We need to do this statistically. Statistical analysis techniques can be applied for annotating the data. Then after that, you try to predict the results based on a statistical data. Yes, we can use the natural language understanding the intersection of NLP and ML. Yes, we can apply the ML also for both NLP technique, because it's the NLP is something that is a part of the process of NLP itself. But when you're understanding the and understanding the whatever the inputs of the input language, the machine learning can be applied there in that particular case of the NLP also we can apply it. It's is accuracy gets improved by the yes, of course, accuracy, because larger the data set you will get because smaller data set what happens is sometimes we not get predictions or accuracy might not be proper. Therefore, if you have a more data set, sometimes what happens, you may not have a more data set also. In that case, some statistical algorithms can be applied and you can utilize your data set. So you can form your own data sets so that the number of data sets and the related neighboring values will be more, so that the predictions can be done in a better Yeah, madam, I think then it was price in the private chats. Hello?
Question, sir. Some more questions are posted. I have just put it in the chat box. Can you see those questions, sir?
Yes, yes. Can we, NLU is the intersection of NLP and ML. Yes, of course, NLP and ML is the intersection of AI, we say, but NLU is a part of the NLP process. It is. When it is a part of the NLP process, automatically the NLU can be used in, because we can, when we apply the machine learning for understanding the natural language, it means that NLU can also be a part of ML as well as NLP. Understanding can be done separately in NLP as well as using some machine learning algorithms. Also, we can understand the data or understand the input to text. Therefore, I can say that NLP is part of both here, NLP and ML, and it is an intersection between NLP and ML. Yes, of course, I already mentioned that accuracy will be improved. Yes, accuracy is improved by the larger data sets. So, to expand the smaller data sets to larger data sets, as I mentioned, we need to duplicate it. Duplicate means related data sets need to be founded by using some statistical data mining technique. You search on the website what the different statistical data mining techniques are there, but not exactly. It will like this. We'll get a naive values where there will be a change in the standard deviation or mean or error like this, so that nearby values will get, and if we have a prediction which is based on the nearby values also, you can predict it, so that your data set will also increase by having the neighboring values where they are where they are fitting onto the particular model, which is having a closeness in the mean, median, and standard deviation values of all the data sets what you have with. Accordingly, you can change the inputs in your data sets so that they will fit to the particular standard mean and what do you call it, the standard deviation of the entire data set what we do. Now, if they are falling onto that particular curve or fitting into that median, mean, and standard deviation, you can use whatever the data values you choose for that. But don't introduce the exact values. That duplicate that whatever entire data set is there, you find out what is the common mean and the standard deviation and average of your entire data set, and try to change the values of your data set so that they are nearer to the mean, whatever the mean of the existing data set. When you take some other values there, whatever the values you take and calculate the mean standard deviation and whatever those mathematical parameters we consider, the mean, average, and the standard deviation like that. And if they are fitting to that particular line itself, in that case closer to those performance standards, then whatever the changes there will be, like changes in the data, then the data set will also give you the correct prediction like that.
Yes, sir. Thank you, sir. Thank you for answering the questions from the audience. Okay, we apologize for the inconvenience caused today. So we will work on this issue for tomorrow's session. We extend our thanks for being the resource person for today's session, sir. Thank you, sir.
Okay. Thank you all. Thank you once again. Thanks to the management of the department and all the people who are directly or indirectly involved in this organizing the FTP and giving me an opportunity to provide whatever the knowledge I have to all the key persons who are doing the research, either maybe students or research scholars or faculty members. Thank you all. Thank you, one and all.
I thank all the participants for your patience. I all are requested to join tomorrow at 11 a.m. for day 2 session, which will be taken by Dr. Pratibha Arche. Thank you all.